I do need to share my screen because those watching at home need to be able to see what we're doing. Okie doke. Now then. So we've started, sorry for the delay, fellas, but we started with example 2. And we said, let us set it equal to 0. So we moved everything over to one side. Has anybody got that factored yet for me? Y'all been sitting here milling around? What you got, Corbin? Nada? No? Oh, tisk. So here's how this factorization would work. Over on the side, I'm going to multiply 2 times 45, and I'm going to get y squared minus 13y minus 90. Remember, when we do the magic method, we are temporarily pretending as though it's one of these easier ones. So in this case, I could look at 90, and I could look for a couple of factors that add up to 13. Let's see here. We got 1 and 90. That ain't going to work. We got 2 and 45. We've got 3 and 30. We've got 4, no, 5, yes. What, 5 and 18? Winner, chicken dinner. So it's going to be y plus 5 and y minus 18, okay? And then what happens? I bring the 2 back, and in one of these, I got to kill it off because that's an extra factor that I don't need. So in other words, 2y plus 5 is one factor, and y minus 9 is my other factor, okay? Don't be afraid to use the margin of your paper or like just an area, a little scratch area, to do like what I was just doing, right? Where you literally just figure out like a sidebar note to how something factors. And then in this case, let me move this up and kind of out of the way here. Andrew, how could I check to make sure that I factor that properly? Oh, no, you would. That's exactly what you would. So, like, check yourself before moving forward in the process. Just take one step back. Foil that out to make sure that first, outer, inner, last matches up with what you're supposed to have. Like, for example, 2y times y, we know that's going to give me 2y squared, right? And then when I multiply, here's the trick. When I multiply the outer and the inner, that's really where I need to focus my efforts. That's the one that will get messed up, okay? And we've talked before about how that's supposed to be the case. So the outer would be negative 18y, and the inner would be positive 5y, and negative 18 and positive 5 make for that negative 13. So the oi right there, the outer and the inner. And then, of course, last times last, 5 and negative 9 makes for negative 45. So in other words, it checks out the way it's supposed to, okay? Now, at this point, I'm pushing you guys, remember, to set each individual factor equal to 0 and hopefully be able to solve it in your head. One of these is a one-stepper, and one of these is a two-stepper. Landon, which one is going to be the easier, the one-stepper? If you were going to have to solve for y in this equation or in that equation, which one would be easier? Yeah, the one on the right. It's a one-stepper. What I mean by that is to get y myself, I only need to do what to both sides? Add 9 to both sides, yeah. So in this case, we get a nice easy y equals 9. Right? Or on this side, what are my 2 steps going to be? What would my 2 steps be, Reed?
Do like cancel out 5 and put it over like, on the other side, and then you do divided by 5.
All right. So when you say, I'm gonna make you give me some more specific details, I guess. When you say move it over to the other side, what operation do you want to perform to both sides? Very good. So when we subtract, we change that side that it's on, but we also change its sign, right? So if it's a positive 5 on the left, we make it a negative 5 on the right. Okay, so we got a 2y equals negative 5. And then I think I heard you say divide. That's the next step. Remember, it's a two-stepper. So we subtracted 5 from both sides. Now we're going to divide both sides by 2, and we get our second answer. Y equals negative 5 halves. Okay? And so there are our 2 answers. If you want, you can write it using a set notation here. You can say, hey, it's negative 5 halves, or it's 9. Ooh, that needs a little work. Let's see here. All right, and so there we go. Those are our 2 answers. Per the fundamental theorem of algebra, we knew we were going to get 2 answers because what kind of equation, Dixon, did we start with? Classify that equation in black. Degree 2 equation. Remember that vocab word starts with a Q? Not exactly, Aiden. Quadratic, good. Okay, so and look, that's not a huge deal, but it just when we're communicating, we properly we use those proper words. So yeah, it's a quadratic equation. Class, what kind of equation is example 3? Quadratic equation there. And so guess how many answers you're fixing to have to come up with? 2. Corbin, you had a hand up.
Is it matter the order?
Not at all. Good question. And that's part of the commutative property, right? Back here when I was unfoiling, when I was factoring this out, I just happened to write it that way. But yeah, you could have reversed the order of the parentheses and gotten, y equals 9 or y equals -5/2. It would not have mattered there. Okay, good question. All right, so I want you guys to try example 3. Again, it's called the zero product property. So your first step should be what? Mm-hmm. Hey, and I like, again, how Reed said move, if it's positive on the right, I'm going to subtract it from both sides, right? Use that inverse op. I didn't say this for the previous example, for example 2, okay, but check this out. Look, you might have noticed, I moved the 13 and the 45, and I had a kid in my freshman class say, Coach Morgan, why in the world wouldn't you just move the 2y squared? Why wouldn't you have just said, let's subtract 2y squared from both sides and kept the 13y and the 45 positive? Isn't that a quadratic equation that has these 2 answers as well? And I said, you daggum right it is. That quadratic equation has those 2 answers. But, ... Lance. And that's just, it's setting myself up for more difficulties if I have that first term to be negative. Everybody remember that. If my first, so in other words, could you technically subtract 25z squared from both sides down here? That's freaking lutely. But you probably should not do that. So as to keep the quadratic term, in this case, that's the leading term, to keep it positive. That's my recommendation to you, okay? You could certainly work it that way, but it makes life easier when we get it done that way. So you should be working example 3, set it equal to 0, try to factor it out. And again, I like how I'm seeing some of you guys flip back in your notes looking at your factorization techniques. This is one of those bread and butter techniques. It's a binomial. And so you'll remember from our little flow chart that when you're factoring out a binomial after having looked to check for a GCF, the very next factorization technique is a difference of 2 squares. See if it's a difference of 2 squares, the DOS. Okay. Now, with the difference of 2 squares, go ahead and move this 49 over. Right? With the difference of 2 squares, it's going to be a binomial times its what? Times its conjugate, right? And so that, remember, that means, this was my favorite factoring technique because it's just so easy. That means that one of them is going to have a plus, one of them is going to have a minus, bless you. All right, so why, can you fill in those 2 gaps, fill in those binomials for me? Split up 25z squared. All right, so 5z and 5z split up 49. And there we go. Very good. So a binomial times conjugate, again, Mr. Denegri's told us we could FOIL it out to check, right? And we certainly, the OI would cancel out there since they're conjugates. That happens. But then I can just set the zero product property into action. I can say, hey, 5z plus 7 equals 0, or the conjugate, 5z minus 7 equals 0. Class, are those one-steppers or two-steppers? There's 2 steps. All right, Adam, you can take either one you'd like, but try to get z by itself for me. Tell me what operations to do to both sides.
On the left side, subtract z.
Subtract what?
Subtract 7.
See, that's my 7s look like my z's. I knew what you meant. All right, so subtract 7 from both sides. I got 5z equals -7. And then last step. Beautiful. Divide by 5. In class, is it okay? I didn't mention this in the last minute. Is it okay to get a fraction? Of course it is. Por supuesto. All right, we'll get a fraction. Now, if you're on your toes, you can go ahead and solve that second one using inspection. You can say, oh, you know what? It's going to be a positive 7/5, right? Same two steps that Adam gave us, all right? And then if I wanted to write it up using my squigglies like you saw in the last one, check this out. You could say z equals, and then you could slap a plus minus 7/5. Mathematicians aren't lazy. We like to say we are efficient. Okay, so instead of writing it out twice, z equals this or z equals, I just write it once. Z equals plus or minus this. All right, and that's the more conventional way of writing your answers. Again, how many solutions did we get to that equation? 2. Dixon, that's because it was a what kind of equation? It was a quadratic equation. Yes, sir. Every quadratic equation has 2 solutions. Okay? Not every quadratic equation factors, however. Okay, so like you might say, well, dang, coach, what would have happened if this had been, like 23z squared equals, 50 equals 57, something crazy like that. Class, what type of equation is that in orange? That's quadratic daggum equation. And from our fundamental theorem of algebra, how many solutions does every quadratic equation have? It's got 2 solutions. You just wouldn't solve that one using factoring in the ZPP. I'll teach you later on in the year, you would use either the square root method or something called the quadratic formula, okay? But suffice it to say, even those uglier quadratics still have 2 solutions. And then last comment before we move on here to the next example, let me kind of zoom back out. Do you guys remember, oh, actually, I've got some pictures up here that we've been talking about this. You remember what the shape of a quadratic function looks like? Parabola, very good. Okay, and a parabola, when we're solving for set equal to 0, check this out. This one right here where I'm highlighting it in yellow. That's a quadratic equation. That's like saying, hey, where does the function f of x equal 2x squared minus 13x minus 45, since we're used to dealing with things in terms of x. If I were graphing this out, where does f of x equal 0, in other words? What that's asking for is it's asking for x-intercepts. Okay, it's asking for x-intercepts. And so this parabola you guys just found, its 2 x-intercepts. Right there at -5/2 and right here at +9. Right, you found those 2 points on the parabola. Every time you're solving a quadratic equation, that's what you're looking for. You're looking for, where does that parabola cross the x-axis? Because on the x-axis, that's where y equals 0. We had it set equal to 0 for a reason. That's where the y value equals 0. Okay? And I told you in green up there at the top, it doesn't really make a difference. That equation is going to have those same 2 solutions. The only difference is everything had been multiplied by a negative. So it would be as though we had this parabola that had those same 2 x-intercepts. It was just upside down. That's the same 2 solutions, doesn't it? Right? It's just you're looking at it from a different vantage point. And so the way we worked, it makes a little bit more sense because the positive leading coefficient made the parabola concave up as opposed to down. All right, enough beating around the old bush. I love these next 2 examples. I think I might have told you this. I was observing Coach Gray's Algebra 1 class the other day, and a couple weeks ago, since they were going through this earlier in the year, and I asked if I could throw this kind of question to them, right? Because this is a really good check to see, does he actually know what he's doing in solving quadratic equations, okay? What property is it that we've been making use of in this lesson? The zero product property, the ZPP. Lest we forget, I'm going to write that down, ZPP. That stands for the zero product property. You see, the temptation in this problem is for students to say, hey, it's already factored. Coach Morgan did my work for me. I'll just set each individual factor equal to, so 3x minus 8 equals that on the right, or x minus 1 equals that on the right. Don't do that. Okay, I shudder to even think that you saw it on the screen and therefore you would want to write it down. That's not what we're doing. It's called the 0 product property, not the 3x product property. Or down here on example 5, which you'll do in a moment, not the 8 product property. You know, they make this mistake so often on this one. They'll say, oh, k plus 1 equals 8, or k minus 1 equals 8. No. Your first step right out of the gate should be to set the whole thing equal to 0. Let's you and I do that together here on example 4. Okay, so first step right out of the gate is we're going to FOIL the two binomials together. We're going to get 3x squared, that's first times first. We're going to get negative 3x and negative 8x, that makes negative 11x. And then last times last is positive 8. So your first step was to FOIL so that you could combine like terms. So that when I subtract that 3x from the right side, he'll have somebody to go with. You know what I mean? So when I subtract 3x from both sides, now I'm cooking with peanut oil. I got negative 14x. I got positive 8 equals 0. And that's now where I can set up and factor and use my ZPP. Okay? Really important for us to understand that before you get running with the ZPP, everything's got to be set up in this nice, neat, standard equation. Okay? Do you remember what I mean by standard equation, where it's in that form ax squared plus bx plus c? You guys know what I'm talking about there? Like, if I asked you, Corbin, to tell me what's a, b, and c for this example, what would you say?
A is 3, negative 14 is 3.
Beautiful. Well said. So be able to identify those coefficients, the leading coefficient, that quadratic coefficient of 3, in this case the linear coefficient is negative 14, and then the constant term is 8. That's going to be so important later on down the road. Be able to identify what a, b, and c are. All right, and if I can't put it in that a, b, c, ax squared plus bx plus c equals 0 form, then I need a little bit more practice. This one's going to be a ZPP. It's going to be factoring out, again, as a binomial here. I think I said ZPP. I meant magic method. Pardon me. Get to talking too fast. Let's see if we can use our margin like we did in the previous example. All right, so 3 times 8 is 24. So we got x squared minus 14x plus 24. 12 and 2 looks like it'll be getting the job done for us. X minus 12, x minus 2. Bring the 3 back. Kill it off where it needs to be. And so we got x minus 4 and 3x minus 2. It's a great idea for me to check myself before moving forward, right? How do you check yourself, Landon? FOIL it back out. Yes, sir. Very good. So I'm going to FOIL that out. X times 3x, that checks. Negative 4 times negative 2, that checks. But really the OI is where I wanted to focus my attention. The outer would give me negative 2x, and the inner would give me negative 12x. Negative 2, negative 12 makes negative 14. So we're good. Okay. Here's where the rubber meets the road. You want to put on your big boy pants? Let's go. So from this point forward, I should be able to jump right down in there and to spot what my two answers would be. Okay, class, tell me what the first parentheses answer would be. First parentheses answer. 4. So it's the opposite. If x is by itself, it's always just going to be the opposite of that number that you see there. Because imagine in your brain, you're saying x minus 4 equals 0. Oh, I just add 4 to both sides. Right? So we get 4 there. And then for the second one, yes, it's going to be the opposite of this number, but then divided by that number. So in this case, it will be what? 2/3. Not negative 2/3, positive 2/3. Because that 2 becomes positive when you move them over to the right-hand side. That's where we need to get. Okay? I have, other than the orange scratch work over here on the right, I have streamlined this problem considerably. Okay? What I mean by that is I haven't wasted any steps. We went from the first bit where we had to FOIL it out, and then we put it in standard form, and we factored, and then in our head, we set each individual factor equal to 0 to solve. Okay? That's where my goal for you guys is, right? To push yourself to get that far. Why don't you tackle example 5 now, okay? Set it equal to 0 first by using FOIL and then combining like terms. Good. I'm seeing some FOIL going on. That's what we need. Some of you have noticed already, even in the first 30 seconds, that this is a binomial times its conjugate. So that FOIL is actually a little bit easier, isn't it? Instead of a FOIL, it's FOIL. Because when you multiply the outer and the inner, they cancel each other out. That's called their conjugates. That will always happen that way. So a nice little shortcut you can take if you recognize that. Good. Very nice, very nice. After you FOIL, that first step, right? After you FOIL, combine like terms. Move that 8 over to the other side. Why in tarnation is there a tube of toothpaste sitting up here? Oh, that's right, I took this away from one of my... I had a senior that was playing with a tube of toothpaste in class last week. I took it away from him. I forgot to give it back to him, though. Oh, well. All right, y'all keep working. Quietly, I'm going to show you what everybody has been doing so far. Just having walked around a little bit. All right. So you're making good progress here, fellas. We said I need to FOIL everything together first, combine like terms so it's set equal to 0. And then we happen to have another difference of 2 squares in this case. I made this problem work out nice and neat for you. Factor that as a binomial times its conjugate. Let me put a little bug in your ear, though. A little word of caution. If you are struggling, where I've put those 2 orange stars, if you're struggling to get from standard form to factored form, you have got to go back and practice your factoring techniques. Where can you go back? You can go to Delta Math. You can practice till your little, fingers are exhausted from typing in your answers. You can practice 20, 30, 40 factoring problems if you wanted to. But if you are getting stuck at that step right there where the orange star is, and that's legit where most guys get stuck when they're first learning this, and you got to go back and practice, okay? And then once you get the factored out form and it's set equal to 0, that's cake from there. Everybody usually takes off and runs with that, okay? So we got to practice, we got to get a little bit better at it, okay? Okay, so any questions that you might have over the examples we've worked so far? We're not quite done yet, but I'm going to stop and make sure everybody's comfy and has had a chance to ask what they want to ask. Okay, now we're moving to the realm of what's called multiplicity. Okay, write that vocab word down. That's a good vocab word for an Algebra 2 student. You guys, once you're done with geometry, you'll be Algebra 2 students, so you'll be ahead of the game having already heard of this. It's called multiplicity. So multiplicity refers to the phenomenon we have where one of our answers shows up more than once. It shows up maybe twice or thrice. Multiplicity is the phenomenon where a root or a solution gets repeated. Okay? I want you to know I'm fighting the temptation. I keep saying the word phenomenon. Does anybody know what I'm tempted to do when I say phenomenon? Huh? Yeah, from the old Muppets show, they would say phenomena, dun dun da da da, phenomena, dun dun da 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 da. Y'all don't have any idea what I'm talking about, do you? Read this? I don't care. Oh, just silliness. All right. So, anywho, what happens here is when a root is repeated. Now, you won't see it coming, okay, unless you happen to have the graph of the equation, but you won't see it coming usually. So, pretend like in example 6, just a normal little example. What would the first step be for example 6? What do I want to do right out of the gate there, Andrew? Even before I factor, set it equal to 0. So we're going to do both of those. We'll set it equal to 0, and then as Andrew pointed out, we'll do a GCF. Okay. All right. So let's see here. 9m cubed minus 60m squared plus 100m equals 0. Very nice. We put that in standard form. Remember, your standard form is where the terms are counting down. They're decreasing their exponents. Okay? That's why I scooted the 60 in between the 9 and the 100. Because I wanted my exponents to count down. Nice, neat standard form. Okay, what degree is this equation? It is degree 3. Fundamental theorem of algebra tells me how many equations does, or how many solutions does this equation have? It's going to have 3 solutions. Keep that in mind, okay? Keep that in mind. By the way, what do we call a degree 3 equation? It's called cubic, whereas a degree 2 is called quadratic. This one's called cubic, okay? All right, and I love Andrew's point. That's my first factoring technique right out the gate is to take out a GCF. In this case, my GCF is just a lonely little m, and I'm going to be left with 9m squared minus 60m plus 100. Okay? Now, y'all smell what I smell? A perfect square trinomial. Dun, dun, dun. How do I check? Let's double check. Is the first term a perfect square? We would all say a resounding yes, it is. 3m times 3m. Okay. Is 100 a perfect square? Yeah, it's 10 times 10. Now, my third check we've talked about before is the most important check. I'm going to circle, multiply the two of them together, and then double it. And if that's the linear term, if that's that middle term, then we're gravy. We're straight. Okay, so look right there. 3m minus 10 quantity squared. That's how it's going to factor out. So 3, let me give myself a little bit more room here. Okay, so we got 3m minus 10 quantity squared. Don't throw the baby out with the bathwater. What do I not want to forget? That M, that GCF, right? Oh, man. And hey, could you make me a little side note for me, please? In your notes, jot this down. I literally want you to write this down. That the GCF, oftentimes we throw it out, right? We forget about it. If you do that, if you forget the GCF, you're going to lose one of your 3 answers. Okay? It's a temptation at the beginning. What I really want you to kind of see with me here is that it's a temptation for some students at the beginning just to say, oh, dang, coach, why don't you just divide everything by m? Wouldn't that make your life so much easier, right? Or, hey, just divide both sides by m. 0 over m is 0. It goes away. You lose an answer when you do that, okay? You lose an answer when you divide away the variable GMF, okay? I suppose I could type that in here. Caution, if I could spell, caution. You lose an answer. What is wrong with my fingers? When you divide away a variable GMF. Okay? That's what we should have written down. Okie dokie. So there we go. Just a reminder for us. Now, it might benefit you, instead of writing it as 3m minus 10 quantity squared, visually at this point, it might benefit you to write it as 3m minus 10 times 3m minus 10. Sometimes it's like, I'm a visual person, so I like to actually see. Look, here are my 3 answers. 1, 2, 3. Okay? We're gonna have one answer here, one answer here, and one answer there. Okay, that's where our 3 answers are going to come from. And where the concept of multiplicity comes in is that first answer, that's just easy. That's just m equals 0. I don't have any work to do there. The second answer, 3m minus 10 equals 0. Do I have to show my 2 steps, or can we get to the answer from here? What do y'all think? 10/3. Thank you. Yeah, because we add 10 divided by 3. Right? I'm pushing you guys, pushing y'all to do that work in your head. All right, so we got m equals 10/3. But then I say, well, wait a minute, this is identical. It's the same factor again, so it's the same answer again. M equals 10/3. And so when I'm writing these up, I remember I told you mathematicians like to be efficient. When you're writing these up, you don't have to write it twice. You would just say, hey, m equals 0 or 10/3. All right, and that 10/3 has what's called a multiplicity of 2. That's the number of times that that root was repeated, the number of times that solution showed up. So 10/3 is what's called a double root. Okay, 10/3 is a double root. Now tomorrow, what I'd like you guys to do, make a note here. I'm going to put a little star. Talk about the graph. What that means regarding our answers, because we're out of time for today. But hey, good job. Practice, practice, practice. Please, 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 please. You got Delta Math work to do. Do some extra practice as needed, and live Jesus in our hearts. Awesome. Thank you, guys. I hope you'll have a wonderful day. And if you're watching at home, same to you.